Our planet is facing the biggest challenge in millions of years. It may not sound like terribly much, but Earth's atmosphere has warmed by 0.8 of a degree since the middle of the 18th century when the Industrial Revolution began. Further rises in temperature are already occurring, and the consequences are far-reaching. The polar ice sheets in particular are vulnerable to a positive feedback loop that boosts the speed at which melting occurs. Ice sheets in the Antarctic are breaking up, and up north the Arctic sea ice has shrunk to its smallest extent yet, raising concerns that summers there might be free of ice by the 2030s or thereabouts. To discuss these worrying developments, the Royal Society of Victoria is hosting a 2-day climate change symposium. Monash University plant physiologist Ros Gledo is a co-organiser of the event, and she's with us now. Welcome to Science Matters, Ros.
Thank you.
It sounds pretty dire, the prospect of a meltdown in the Arctic. Is it something we should really be very worried about?
Yeah, I think it is a real concern. There's two concerns. One is to do with the actual rising sea level itself of a few centimetres, which can cause inundation. But I think once you get that feedback cycle and you don't have sea ice in the summer, then it's a dark colour and it absorbs even more light, and you'll get even more melting. And then that will have a flow-on effect, and we could end up with quite large sea level rises as a result of that.
Now, to what extent do things like ocean cycles and solar cycles affect global warming and climate change?
One of the things with the solar cycles, I think that's been shown that it can't account for the differences that we're seeing and the rise of sea level and of climate change we're seeing now. And with the ocean currents, I think one of the things that's going on there is that if those currents break down, then we could see major shifts in climate.
So how are plants going to be affected by these rises in temperature?
There's two real ways that plants are affected. One is directly through the effect of carbon dioxide, and that can cause an increase in growth and possibly an increase in yield, but probably a decrease in nutritive value, so less protein, both in leaves feeding to grazing animals and also in grain. The other side is through changes in climate. So if we have changes in drought, for example, that will affect the distribution of species, biodiversity, and also areas that can be used for agriculture. The key thing is that it looks as if the drought zones will move a bit further away from the equator, which means that where our current droughts are in Australia, which are a little bit further north, that desert zone, will move a little bit further south, and that pretty much goes right through the wheat belt.
So in a nutshell, how can we adapt to these sorts of things?
Well, I think in terms of agriculture, I think we need to think about what varieties we're growing. We need to think about what crops we're growing, whether we need to be changing those sort of things. In terms of water management, we need to look at how we need to adapt to perhaps different water supplies, more extreme rain events. I think if we pull together and all work towards something, then there is the chance that we can actually solve these problems. I don't think these problems are unsolvable. I think the things that make me sad is that we will see a reduce in biodiversity, and we will see certain things change in that regard. But I think we really have to work now to solve these problems, because really 2030 is not very far away.
Ros Gledo, thank you very much.
Thank you.